In this module, we'll directly compare today's correspondent banking rails with emerging on-chain rails built on stablecoins. You'll see where steps disappear, where costs and delays shrink, and where new risks and operational challenges show up. Think of cross-border payments as the same basic job: move value from A to B. What changes dramatically is the infrastructure doing the work. Traditional correspondent banking is hop by hop. Each intermediary holds pre-funded accounts, passes SWIFT messages, and reconciles its own ledgers. That adds fees, FX spreads, operational effort, and typically leads to T+1 to T+3 settlement. On-chain rails compress many of those hops into a more direct, peer-to-peer transfer. A stablecoin moves across a blockchain with near-instant finality. You trade complex human coordination for deterministic code and shared infrastructure. Traditional cross-border rails string together multiple correspondent banks. Each hop adds its own fee, FX spread, and compliance checks. The result is a higher all-in cost, longer settlement times, and lots of operational reconciliation. With on-chain rails, that path is much shorter. You still start and end in banks or licensed partners, but in the middle, a shared ledger handles transfer, and often FX messaging and settlement can be tightly coupled, so every party is looking at the same state. The trade-off is fewer intermediaries and clearer settlement, but more dependence on the chain itself, its governance, and its connectivity to fiat. In traditional cross-border rails, the economics are like an iceberg. You see wire fees and lifting fees, but most costs sit below the waterline. Opaque FX spreads, correspondent markups, network overhead, and idle nostro liquidity. On-chain rails unbundle that same stack. You can point to gas fees, on and off ramp fees, stablecoin or FX spreads, and wallet infrastructure costs. Nothing magically disappears. It becomes itemized and measurable. For decision makers, moving from bundled and opaque to granular and visible is what enables real cost analysis and targeted optimization. In traditional cross-border payments, most of the pain lives in the blind spot between initiation and final credit. Cutoff times, batch processing, and weekends stretch a simple transfer across multiple days, with limited visibility and a lot of operational work to reconcile what actually happened. On-chain rails invert that model. Execution is effectively 24/7, 365. Each transaction is broadcast, ordered, and confirmed by the network, using cryptographic proofs instead of overnight batches. You can monitor progress in near real time via a block explorer, and once finality is reached, settlement is done. Usually in minutes, not days, with far fewer places for funds to get lost. Reconciliation is where traditional cross-border rails really hurt. Today, your core banking system, SWIFT gateway, and nostro accounts all hold slightly different views of the same payment. Operations teams babysit these breaks with manual reconciliations, MT199 and MT299 queries, and endless email threads. Every hop adds timing differences, format differences, and opportunities for human error. On-chain rails replace those partial views with a single source of truth. Instead of stitching together 3 or 4 versions of reality, both sender and receiver read the same shared ledger. The state of the payment is deterministic, time-stamped, and final. Reconciliation shifts from detective work to a simple, authoritative lookup. In the legacy model, each intermediary bank runs its own KYC and sanctions checks. That means repeated screening, inconsistent rules, and a lot of manual friction. You also lose context as data gets truncated or reformatted at every hop. On-chain, the pattern changes. KYC is concentrated at the on and off ramps, where customers enter and exit the crypto ecosystem. In between, the blockchain provides a single global dataset. Analytics tools watch flows end-to-end, score risk, and detect patterns like clustering. You trade duplicated checks for shared visibility and continuous monitoring. Moving cross-border payments on-chain doesn't eliminate technical risk, it reshapes it. On traditional rails, you worry about batch failures, downtime in RTGS or ACH, manual data entry mistakes, and classic counterparty credit risk. These are operational and process-heavy issues you already know how to manage. With on-chain rails, the center of gravity shifts toward key management, custody design, vendor dependence for nodes and APIs, and potential smart contract bugs. Success isn't about having less risk, it's about deliberately reallocating risk into domains you can control with better tooling and governance. Putting this together, a clear pattern emerges. On speed and availability, on-chain rails usually win outright. 24/7, near instant, no cutoffs. Traditional rails can be tuned, but they're constrained by time zones and batch windows. On cost, especially for high-frequency or small-value payments, on-chain rails are typically far more efficient. Traditional rails can still be competitive for large, infrequent payments where spreads are negotiated. Transparency is where on-chain fundamentally changes the game. Shared, real-time state instead of status chasing. The main trade-off is integration effort. On-chain requires new plumbing, governance, and operating models that you'll need to design deliberately. The core idea is not on-chain replaces traditional, but use each where it's strongest. Traditional rails remain well-suited to very large corporate payments, major currency pairs with deep liquidity, and corridors where long-standing correspondent relationships and heavy regulation are actually advantages. On-chain rails shine when you need 24/7 settlement, including weekends and holidays, or you're handling many smaller payouts, like gig or marketplace flows. They're also powerful in emerging markets with patchy legacy infrastructure, and when you need to spin up new payout partners or corridors quickly. Now it's your turn to put everything together by blueprinting a single corridor. First, choose a very concrete flow, a currency pair, direction, amount, and customer type. Next, sketch how that payment moves today. Each bank, provider, hop, delay, and fee. Be honest about the frictions. Then, design an equivalent on-chain version. Which asset, which chain, which wallets, what on-off ramp, and expected confirmation time. Finally, compare the two. Where do you actually save time, cost, or capital? Where do governance, compliance, or integration complexity go up? Use this blueprint as the starting point for your internal pilot proposal.